Hi again. Now we're going to look at writing numbers in scientific notation. So just try to see whether you can remember what it means to be in the scientific notation form. Okay, so we're going to look at some numbers. Okay, so if you remember scientific notation, a number is in scientific notation when it is in the form of a times 10 to the power of n, so a factor or coefficient multiplied by 10 to the power of some another number, right? So, and a is, all right, has to be greater than or equals to 1 and less than 10, and your power of 10, this n has to be an integer. Let's look at some examples and see whether these numbers are in scientific notation. So let's look at some examples. All right, so the first number is example 1, so 2 times 10 to the power of -9. Example 2, we have 0.5 times 10 to the power of 6, and we have, the third example will be 24 times 10 to the power of -2. The fourth example will be 1.6 times 10 to the power of 1.5, and then the fifth example is 9.9 times 10 to the power of 0, and the sixth example is 1 times 10 to the power of 1. So take a moment, pause the video and look at each example and see whether they are in scientific notation, and if they are not, why is that so? Okay, so let's look at the first example. 2 times 10 to the power of -9 is in scientific notation. So this number 2, the factor, is it greater than 1 and less than 10? Yes, it is. And this number, the power of 10, is it an integer? Yes, it is. So this is in scientific notation. All right, let's look at the second example. 0.5 times 10 to the power of 6. So 0.5, is it greater than equals to 1 and less than 10? No, it is not. So no, this number is not in scientific notation. Okay, and let's look at example 3. 24 times 10 to the power of -2, is this in scientific notation? So you could see that 24 is actually greater than 10, so it is not in scientific notation. Number 4, 1.6 times 10 to the power of 1.5 is in scientific notation. Let's look at 1.6. Yes, it's greater or equals to 1 and less than 10. Okay, the power, however, is not an integer, so this number is not in scientific notation. Another example, number 5, 9.9 times 10 to the power of 0. So 9.9, is it greater than or equals to 1 and less than 10? Yes, it is. 10 to the power of 0, is that the power of 0, is this an integer? Yes, it is. So this is in scientific notation. And we have 1 times 10 to the power of 1. Is 1 greater than or equals to 1 and less than 10? Yes, it is. And 10 to the power of 1, is the power 1 an integer? Yes, it is. So this is in scientific notation. So you could see over here we have some numbers that are in scientific notation, some are not. So something for you to think about, if we have example like 2 and 3, how can we write it in scientific notation? So let's look at how we can move. Let's look at this number here. So it was 0.5 times 10 to the power of 6. In order to make it, we have to make sure that this number 5 has to be between 1 and 10, and also the second example here, 24 times 10 to the power negative 2. We will look at it again later on how to write them into scientific notation. So I will now look at how we can convert some numbers into standard form and into scientific notation. So if we have some numbers in standard form, so I'm going to write here 86,000, okay? And second example, we have 0.0024, and we have another number here, 1,650,000, and we have another number here, 0.00002005. So take a moment to just pause the video and think about how you can write these numbers, in scientific notation. Okay, so the first number that we have is 86,000. For number in scientific notation, we know that the number has to be in the form of a times 10 to the power of n. Okay, a has to be between, has to be greater than or equals to 1 and less than 10. So I'm going to first look at this first number, 86,000. So I have the key thing is to put a decimal point after the first non-zero leading digit. So you see that it's 8.6. So it is 8.6 and times 10 to the power of an integer. And we know that 8.6, to make it into 86,000, I would have to move the decimal point. So one place, 2, 3, and 4. So it's 86 times 10 to the 4th power. Okay, so 86 times 10 to the 4th power. So if you can always check it back to see whether you get the same number. For example, if you have 8.6, you want to check it, 8.6 times 10 to the power of 4. So 1, 2, 3, 4. Do you get 86,000? Yes, you do. So that's the answer. This is the answer, right? And for the second example, I would have to put a decimal point at 2.4, right? So the first leading non-zero number is 2. So 2.4 times 10 to the power of. So it's 2.4, and we will have to move the decimal point to 1, 2, 3. So it is 10 to the power of negative 3. So remember, this number, the second example, the number is smaller than 1. So it has to be a negative power. And the first example, the original number is greater than 8.6. So it has to be a positive power here. Okay. So the next example, 1,650,000. So you can see that the first non-zero leading number is 1. So you'll put a decimal point here at your 1.6. So 1.65, okay, times 10. Again, this number has to be bigger. It has to be a positive integer power because it's bigger than 1. So I'm going to move it. So 1.65 going to be 1, 2, 3, 4, 5, 6 times 10 to the power of 6. Okay, and the fourth example, the first non-leading zero integer digit will be, so you could see it's actually here. So you have to write it as 2.005 times 10. Okay, and we know that this number is less than 1, so the power has to be a negative integer. And if you move the decimal place, it will be 1, 2, 3, 4, 5. So 10 to the power negative 5. Okay. Next, we're going to look at how we can write from scientific notation to standard form. And standard form, so in this case, we have two examples. So 30.22 times 10 to the power of 7, and the other example is 7.9 times 10 to the power of negative 8. So maybe you want to pause the video and give yourself some time to work it out through before looking at the answer. So Okay, so now we're back at looking at the answer. So the first example, 3.22 times 10 to the power of 7. So we know that we have to move the decimal point 7 places. So this becomes, so 1, 2, 3, 4, 5, 6, 7. So the final answer for this will be 3, 2, 2, and then how many more zeros? So it will be 1, 2, 3, 4, 5. 5 more zeros. So 1, 2, 3, 4, 5. Okay, so it's actually 32,200,000. Okay, and the second example is -8, and we know that the number gets smaller when it's in power of -8. So you can write it as 7.9, and you have to move it to 7.9. You have to move it to the left, the decimal point to the left. So you move 1, 2, 3, 4, 5, 6, 7, 8. So you could see that how many zeros are there. So there are 1, 2, 3, 4, 5, 6, 7. So 7 zeros after the decimal point. So the answer would be 0.1, 2, 3, 4, 5, 6, 7, and then 7, 9. So this will be the number in standard form. It can get really confusing with positive powers and the negative powers, and this is where a lot of people be asking, a lot of students asking, is there any rules that we can apply here? So something that you want to check is that, for example, the first example here, 86,000, this number becomes smaller, so it's from 86,000 to 8.6. So what happened is that when this number becomes smaller, the power will become bigger. It's an increase in power. Okay, so same thing for the third example, 1.65 million. So you see that this number became smaller, so this number will become bigger. Something that for you to think about. So, and if the number, say 0.0024, it became bigger, all right, so the power has to become smaller. Okay, and the fourth example, 0.00002005, number became bigger, so the power has to become smaller, kind of like to offset the value. So something for you to remember as the rule. Now we're going to go back to the two examples that we saw that were not in scientific notation, 0.5 times 10 to the power of 6 and 24 times 10 to the power of -2. And we're going to write them in scientific notation. The other example of 10 to the power 1.5 is not possible, so we're going to just focus on these two examples. So 0.5, we know that you have to first write this and convert this into maybe a number in scientific notation. There will be the first leading non-zero digit will be 5. So it will be 5 times 10 to the power of, in this case will be, because we move the decimal place 1 to the left, so it's 5 times 10 to the power of -1. And we're going to keep the the number on the right, which is 10 to the power of 6. And now we're going to use what we know about indices or exponents to combine these two numbers. So 5 will stay as a 5. And remember, when you multiply two bases, what do we do to the exponents? So you actually add them up, right? So it's -1 plus 6. So this number becomes 5 times 10 to the power of 5. Now we're going to look at the second example, 24 times 10 to the power -2. We know that 24 is not in the the factor that we want. So we're going to write it as, so if you look at the first non-zero leading digit will be 2.4, right? So it's 2 and then 2.4, okay? And 2.4, if you rewrite it 24 as the 2.4, that will give you 2.4 times 10 to the power of, if you apply the rule, if this number becomes from 24 to 2.4, so this power becomes to the power of 1, okay? So if it's actually 24, and then you're going to move the decimal place, so it's 2.4 times 10 to the power of 10, and we keep the original, 10 to the power negative 2. And now we can rewrite this as 2.4 and combine these two exponents using the product of bases. So it's 2.4 times 10 to the power of 1 minus 2. So you get 2.4 times 10 to the power of negative 1. And that's it for writing in scientific notation. So please watch the video on operation in scientific notation. See you.